so starting from the top, so I've got a couple of different questions around minimum night flow measurements. One, there seems to be interest in being able to share or access more detail or parameters for minimum night flow measurements as a perhaps a toolbox item would be one. And then there's a specific question regarding minimum night flows. How does a utility take into account facilities such as stadiums because they can distort results, say for a large night soccer match?
I'm working, Neil and I will answer from the same computer at the moment. On the minimum night flow, the South African Water Research Commission has published a booklet which is based on the UK water industry's recommendations, and it explains how to interpret the minimum night flow, and it gives you all the parameters that you use in order to calculate what the expected minimum night flow should be. I think it's 3 litres per connection per hour and about 20 to 40 litres per kilometre of mains per hour. This is all at pressure of 50 metres. And in cases where you have a football stadium or maybe a university or an industry that's a large user, you have to monitor the water meter for that specific user and get the individual nighttime use so that you can deduct or you can add that on as an expected minimum night flow. So where in a zone where you have mixed use, where it's not just purely residential, you need to establish whether you've got a service station or you've got a laundry or a brewery or an industry. And during your exercise of minimum night flow, you need to make an estimate of how much water that particular user used. And you would normally do that by visiting the water meter between midnight and 4 o'clock in the morning and taking measurements so that you can get an estimate of what their hourly consumption is. And that you then take into account in your calculation. What I can do is I can provide the RockBlue with a digital copy of the SandFlow user guide, which you can also get the software with that. It's free of charge. I mean, it's public domain information. And I've also got a paper that's written on how to interpret minimum night flow. And to whoever asked that question, they may find that helpful. Thank you.
Thanks, Ronnie. That's very helpful. If I could suggest, I'm trying to figure out the best way to get the link out to that paper to the audience. Thomas, perhaps you can clarify whether that's something that we can email to the participants, or if it would be better to post the link up on the chat group.
In the survey at the end of the webinar, there's a space for them to fill in their email addresses if they wish to have further educational material. So we'll include it in that if they want to fill in their email addresses there.
Thanks for the clarification, Thomas. So another reason we want to encourage you to participate in the survey at the end of the Zoom session. Please use that to provide us your email address, and we can respond with a copy or a link to where you can access that paper on calculating minimum night flows. Here's an interesting consideration. So when we do our pressure zone management and we account for minimum pressure levels in our various zones, you take into account the current state of play, which includes leaks in the system or losses in the system, which obviously has an impact on pressure. If you're doing pressure management then and trying to set an appropriate pressure level that gets your minimum pressure levels at peak demand, how do you balance that against the leaks in the system? Or are those existing leaks then a threat at peak demand on total system pressure?
I think on that one, it's a balancing act. It's a two-part issue. If you've got leaks in the system that give you that exist, and you set the pressure for your critical point to be 20 meters, if you subsequently come along and you fix the leaks, then the system pressure will increase. And if you don't reset that system pressure and bring it back down using your pressure reducing valve, then it will actually revert back to where it was within a year or two. It will create more leaks. So it's a balancing act. When you go into an area to identify and fix leaks, you tend to as soon as you fix a leak and you do a leak repair project, you will push up your pressure, and you subsequently have to go back to your pressure reducing valve and try and drop it again. Otherwise, you will undo all the benefit. The leaks will just keep reoccurring. So it's the pressure that is causing the leakage. So when you fix the leaks, your pressure increases. You then need to drop it back down again. Otherwise, the leakage will occur, and it's the leaks that will bring it down. So it's a balancing act, and it's almost a continual fight. It's not something you do once and then walk away for 5 years. It's a continual. It's like getting religion in the water loss management field.
We have snakes and getting religion now. So here's a question that I think Neil's presentation answered very clearly, but it ties into another question that is raised up. So the question is, do PRVs go bad? And I think you've shown us some pretty good examples of when they do get bad. What would a utility or water service provider need to have access to in terms of facilities and equipment and training to adequately maintain the PRVs in their system? Let's assume a fairly simple PRV asset register within the utility.
Right. So yeah, so Chris, as you mentioned, PRVs sort of can go bad, or something with the PRV can go wrong. The fortunate part is that all the parts in a PRV can be replaced. So if only one of the parts sort of would get damaged, then if you service the PRV, only that one part can be replaced. Only when the valve body, the whole casing of the PRV is damaged through cavitation, then you have to replace the complete PRV. But if one of the components inside the PRV fails, you can replace it. In terms of what water suppliers would need, I think Ronnie touched on it earlier, that it would be advisable that at least some of these staff in the water utility receives training on the operation and maintenance of PRVs. It is a bit more involved to work on a PRV than to work on isolating valve or a normal pipe in the network. There's a bit more to it, and we find that when we do these courses with water utilities, there's normally a sort of a smaller group in the municipality that really understands sort of the PRVs, and they can then sort of go on and do the servicing. The actual tools that you would use for the PRV servicing would be tools that any normal operations team would already have, and we would recommend that you have some spare parts available for the PRV makes and the PRV sizes that you have in your network, to have those spare parts already available. So when you do the PRV servicing and you take the PRV apart and you see that a component is damaged, then you can replace a component right there and put the PRV back together and service it. So that's a few topics touched there. I don't know if that's sort of sufficient, Chris.
I think that goes a long way to answering that question. In your presentation, you referred to the ZNet software and obviously demonstrated how effective it is at allowing management of your pressures. How is that a package available online? Is it freeware? How do people use that? Is there different scales for different size utilities? Can you address the commercial aspects of that?
Right. So ZNet is a software package that WRP developed. It's not freeware, but you basically pay a subscription fee, which is either sort of monthly or annually, and it's dependent on the number of loggers or devices that you would have in the field that would then send data sort of to the ZNet platform. So obviously and sort of the higher the number of loggers, there would be a different price structure, to someone that would have only one or two loggers. Maybe if there are some of the delegates that would like to have more information, they're welcome to send either an email through I think the feedback form that you mentioned, or they're welcome to email myself or Ronnie directly, and we'll be able to supply additional information for that. And we'll also be able to provide a demo login. If there are some of the delegates that would maybe just like to log in to ZNet and see how it would typically look like and what are the features, we'd be happy to supply a demo login.
Great, thank you. There's the next question from Futo Hulo says, I'm getting quite a bit of feedback there. Clearly, zoning is central to pressure management. In a situation where you have an unzoned network, where do you start? What is the key determinant of the zone size, boundaries, etc.?
Right. So in an area where you don't have any pressure management at this stage, my recommendation would be to get your GIS, your drawings, as accurately updated as possible, and to then go through a process which we will probably set up an hydraulic model, and then on that hydraulic model you would basically model different PRV zones. And Ronnie mentioned some of the factors earlier. You would basically look for things like rivers or highways or railway lines, natural sort of boundaries where your PRV zones can fit in. You would want to minimize the number of PRVs per zone, because each PRV that you add is a PRV that needs to be maintained. You would like to minimize the number of boundary valves or valves that have to be kept, because again that involves more maintenance. You would like to minimize the elevation drop in the zone, because if the elevation drop in a zone is going to be very high, you're going to have to set the PRV to achieve the optimal pressure for the highest point in that zone, which will mean that the lowest point in the zone will necessarily have still very high pressures. So there's a number of factors that you would take into account. And I find that if there's no pressure management in the zone, the best starting point would be GIS and then hydraulic model, and to then basically model different zones, taking these factors that we've mentioned now into account, and come up with the sort of most optimal design, PRV design for that specific network. And the zone sizes can vary. There are PRV zones where we've looked at, which is maybe 300 properties. And there are PRV zones that we've looked at. Ronnie's shown some of the examples in Kailicha and Mitchell's Plain and Sebokeng, where the zone size is 50,000 properties. So I think in each case needs to be sort of handled, in its own merit, and look at the optimal solution for that specific zone. Chris?
Fantastic. Sorry, I was just muted there. This is a great discussion, and moving beyond the PRV, and the metered and the detailed approach. I mean, many of our audience members come from much less developed systems or utilities, and they don't have good metering. And in your experience, or in Ronnie's experience, they want to know the best method for controlling physical water losses in an unmetered network, or another way to say that would, how do you do pressure management in an unmetered network?
Right. So pressure management, as we've shown now, you need to identify a zone for your that where you will control the pressure. If you were to install PRVs just on random pipes for the sake of reducing pressure without creating a discrete zone, your PRVs is not going to achieve much. So if you want to reduce the pressure, you would need to look at a drawing, either manually or an hydraulic model, and determine where will the zone be located, and then place your PRV, basically to control the reduction in that zone. If you are going to install a PRV as a new installation, we would recommend to install a flow meter with the PRV, because it's always useful to monitor flow and pressure at the same time. If you have an existing PRV but there is no flow meter, there are means for you to determine maybe a temporary flow logging, either through a clamp-on meter, or you get devices that actually plugs into the side of a PRV, and then you can also measure flow through the PRV. And the flow of, is also quite useful, because you can then measure the impact, the water savings that setting the PRV will result in. If you're not logging flow, you will see that the PRV is working, but you will have no means of quantifying, what was the impact of this exercise. Chris, I'm not.
Yeah, that's exactly. Yeah, it's
sure
spot
if
on.
that sort of covers, or if the question is also on in areas where pressure management is not an option, whether what physical loss reduction options you would then look at. I'm not sure if that was part of the question.
I think that's a great lead into exactly that point. And I'm going to bring up another context there. There's another question that's interested in your experience, either data-based or anecdotal evidence, of where's the break-even point for investment in a demand management or a pressure management, zone management approach versus leak reduction.
Right. So I think Ronnie touched on it sort of earlier, that our experience shows that pressure management is with quite a sort of big margin, the most cost-effective means of reducing leakage. We've got many examples of small, medium, very large zones where savings sort of were generated through pressure management. Leakage reduction, if I understand correctly, in terms of active leak detection and then repairing those leaks, if that's
That's
what
right.
what the question sort of refers to. Obviously, that's also important to do as another aspect of water loss control. But in our experience, the effectiveness and the savings you will generate from active leak detection and repair is not sort of comparable to what you will get with pressure management. So both are important and both needs to be done. But if there's any way possible for you to do pressure management, that should be your first priority. If there's no means at all to do pressure management, then obviously you will have to focus in on what you can, which will include leak detection and repair.
Maybe just cut in on that one. Just add a little piece to that to touch on what Neil's mentioned. When it comes to leak repair, there's two components. Neil's touched on active leakage control, which is the process of sending teams into an area to look for leaks using leak detection equipment. What we find is passive leakage control, which involves repairing leaks that are reported, is very cost effective. It's similar in many regards, maybe even better occasionally to pressure management. If you know of a leak that has been reported, that is by far the best thing you can do, is to repair that. What Neil and I both agree on is that when it comes to sending teams in to find leaks that have not been reported, that is not as cost effective perhaps as basic pressure management. But certainly fixing leaks that are reported and fixing them quickly within 24 hours or 48 hours, that is a measure that any water utility should do as a priority. And we don't question that at all. And in many cases, that is a higher priority, perhaps even than pressure management. Fix all reported leaks within 24 or 48 hours. That is your biggest saving that you can do. So it's when it comes to looking for new leaks, then it's questionable, especially our experience is that many water utilities are not even fixing the leaks that have been reported. And in my view, it is not cost effective to go and look for new leaks when you're not fixing the ones that you already know about. Thank you.
Hey, Ronnie, that's great. Would it be then accurate to say that if we were going to do a hierarchy of prioritization on leak reduction, you would start with get your repair teams in place that they can fix reported leaks. That's option one. Let's get that 24 hours. Okay. So number two, then would investment in improving the systems to report leaks. In other presentations I've seen you give, you mentioned WhatsApp used where a member of the public can use their mobile phone to take a photo, send a geotag, and that goes into a central reporting, because then now you've got that reported leak location.
Could you, clarify the question there? You say, is that something we would approve? I think that's I think using that technology, cell phone technology, especially if someone can just press a button and it records their location and a picture of the leak, I think that is an extremely valuable way of using modern technology, because even throughout the whole of Africa, I mean, we go to places where people say they can't afford to pay for water, they can't afford to pay for electricity. Everybody's got a cell phone that can take a picture and it can be geo-referenced. So I believe that is fantastic technology. There's a number of apps that are available that do exactly what you're suggesting, and I think they are excellent. And I think it's a great way of water utilities being advised where leaks are. And that is one of the best things they can do, is repair reported leaks quickly. That is without question the best thing they can do. And an app like that is perfect. I mean, it's using technology that is available that everybody seems to have these days. So I think that's brilliant.
Fantastic. Our final question, I think, is just touching on the efficacy of NRW pressure management interventions. In your experience, or in the projects that you have implemented in South Africa and regionally and wherever, across those examples, what kind of reduction levels have you managed to achieve? NRW ratio at beginning of project and compared to a final ratio?
Okay, that's a great question, actually. We've worked, Neil and I have probably worked in over 22 countries around the world. And we've experienced zones which have leakage levels of 90% or more. So in some cases, we've gone from 90%. We've managed to reduce, in cases of 90%, we've come down to 30%. So we've managed to take 60% off. That would be an extreme case. That would be a case where there's leakage just bubbling out the ground everywhere. It's not difficult to find. It's just totally been neglected. I would say on the Kailicha installation, which was the first installation that we worked on, pressure management reduced the total consumption, I would guess, by about 20% to 30%. Once you've done that initial pressure management, the next phase involved going into the houses to repair plumbing leaks, etc. It became a more hands-on, difficult task. So pressure management tends to be your first level, biggest bang for the buck type intervention. Once you've done that, the next intervention is typically going to be more problematic, take more time, give you less benefit. So I would say pressure management generally gives us, I would guess, on an area with reasonably high leakage, we would normally expect savings of between 15 to 30% just on pressure management. Neil, maybe you've got more. Neil's done the 800 in Joburg, so he can maybe give you. It depends. It depends how well the pressure zones have been maintained and whether or not the leakage levels are at 30% or 90%. If it's as high as 90%, you should be aiming to get down to 20% at some point. It may take you 5 or 10 years to get there, but that is an achievable number in most systems that we work with. Neil, maybe you want to add on that?
Yeah, I think the order of magnitude that Ronnie mentioned there is sort of, in line with what I would expect also. What we are finding in many municipalities, that if you do a pressure management project on the one end and make big savings, then on the other side of the town, something happens which sort of creates the opposite, sort of additional additional leach, sort of something not related sort of to the pressure management project. So there are few municipalities which I've seen, which literally throughout the municipality implement projects to sort of to reduce the non-revenue water for the complete municipality. There are a few cases available, and two that I think of now, and there are presentations available on that. The one is called Drakenstein municipality, which is the Paarl area in the Western Cape, and there they implemented over a span of maybe 10 years a number of initiatives which included pressure management, and they reduced the municipal non-revenue water. I think it was between 20 and 30%, somewhere in that range, and they reduced it, Ronnie, can you recall, I think to the 12% or something?
They got down to 11%,
okay.
And they were originally up over 30 at one point.
Okay. And the same with Oeverstrand municipality, which is the Hermanus Kleinmond area. They also had sort of similar results. So, and the reason why those two municipalities were quite effective in reducing the overall municipal non-revenue waters, they had personnel there which are dedicated and knowledgeable, and they basically implemented the one project sort of after the next, and they were able to to achieve that.
Thanks, gentlemen. I do have a couple of other questions in the queue. However, we are at the end of our system, our presentation here. I would encourage those participants that do have questions, please engage with us at rockblue.org. Provide questions or comments in the survey that's going to follow us now. So with that, I would like very much to thank our presenters. Neil and Ronnie, you've given us a lot to think about. I've learned much more about pressure management than I knew an hour and a half ago. So thank you for your time on this Thursday afternoon. I'd like to thank our participants thank you for engaging with us on the Q&A session. I realize my video has been muted here. There we go. Thank you for sticking with us. We look forward to your feedback on the survey. And I want to take this opportunity to invite everyone here today to join us for our next lecture series. It will be on June 4th with Dr. Jeremy Gorelick, a close friend and colleague of mine. Jeremy is an expert in mobilizing investment into the water and sanitation space. So he will be speaking about where to find the money for this kind of intervention. So if you want to get into pressure management, in a couple of weeks, Jeremy will help speak to where you can find support for financial support for that. Once again, reach out to rockblue.org. Please consider participating either on our roster of experts. We are a non-profit organization and are always welcoming donations of any size and other support. So we look forward to hearing from all of you on the survey. We look forward to engaging with you in the future and welcoming you to our next lecture series. Thank you and good night.